right, so we're going to get started. Thank you for coming. We know that we are under a very intense competition from a talk that has Kubernetes in it, right? Because anything that's got Kubernetes in it must be the best and the most beautiful and whatever. Whereas here we are talking about, well, the talk is billed as Ceph, the good, the bad, and the ugly. And I want to add something to that, which is the good, the bad, the ugly, and the unknown, which sometimes is the scarier part of the whole thing. Okay, so who are we? Of the two of us, Orit is clearly the more knowledgeable person on the subject, because she actually works on Ceph for Red Hat, or at Red Hat, now back in Israel after some time in the Netherlands,
Correct.
and back at Red Hat after some stints at other places, right?
Correct.
But she actually hacks on Ceph. So she actually works in the development team. I think formally you all report to Rick Wheeler, right? So Rick is also an Israeli national, as it happens, who is the lead of the storage and file systems team, and sort of unofficially, it's primarily Sage Weil who leads the Ceph development team, and Orit specifically works on the Rados Gateway component of Ceph. And I'm Florian. I don't work on Ceph, but I work with Ceph for quite some time. I've been in Ceph projects going back to about 2012, and I've seen a fair number of things that people have done with Ceph, and a fair number of things that people attempted to do with Ceph. Some of them were a good idea, some of them were not such a great idea. And the way that we're structuring this year is that Orit and I are going to have a little sort of fireside chat, and there's a few issues and things that I've run into that I'm just going to grill her with. And of course, I said this in my workshop earlier, I'm in Israel, so I don't need to remind you to ask questions because you're just going to shout them out anyway, which is good. So we're perfectly fine with that. And we want to start out with the things that are admittedly really good. They're working really well in Ceph. Okay, so the first question that I want to ask you is, like year in, year out, the OpenStack Foundation does this thing that it calls the OpenStack User Survey, and every single time when it comes to like storage options, Ceph pretty much comes out on top. And the reason for that is pretty much RBD, the Rados block device. And maybe you want to tell us a little bit about what RBD is actually about and what it's good for and how it integrates with OpenStack.
So RBD is
not... Mike?
Now it's okay?
Better?
Okay, so RBD is not just a block storage, it's block storage for VM images. And it integrates really well with QEMU, KVM, which are the hypervisor that usually OpenStack uses. And it has all the feature images needs, like cloning, and we also have journaling.
What?
Sorry.
There you go.
I'm
That's
not
better.
good with external mics.
So we know that RBD is like very popular as sort of a block storage device, right? But as you just mentioned, there is a whole lot of like interesting things that you can do with cloning and snapshotting and so forth. And as it happens in OpenStack, that is very tightly integrated with 3 different sub-projects of sorts in OpenStack, which are Glance and Cinder and Nova. And now, can you tell us a little bit about sort of like what are the specifics of that tight integration? Like, for example, if I fire up a VM in, say, for example, a public cloud, and that public cloud happens to be backed by Ceph, and so Glance uses Ceph RBD images, my Nova VMs use RBD images, my Cinder volumes use RBD images. Like, what's my benefit? What are the things that actually help me, or how are the ways that Ceph actually helps me with that? So what's cool about that? What makes it more efficient? What makes it faster? What makes it nicer to handle than when I use some other, like for example, LVM and iSCSI and so forth?
So first of all, Ceph is distributed, so you have the distribution. So you have good throughput, and you have high availability, and we do the replication. And then we have, everything is done automatically, so the cloning can be done and those stuff.
Right. So, like, what does that mean? Because normally if I'm firing up like a VM, then normally, I have a glance image that's being like a stream down from glance to like my Nova host, and if it's a large image, say for example, that's a Windows image, it's like 20 gigabytes and whatnot, then that takes forever. It takes something like 5 minutes. So if I do that in a Ceph-backed cloud, then that works much faster. Now, why is that exactly?
Because we don't copy the image is there, and because we are distributed, so you have the image everywhere, and you can access the image from any node, so you don't have to copy it to the Nova node.
Okay, so basically what I can do is I can use this sort of like awesome distributed storage capacity that I have there, where I maybe have like terabytes or even petabytes of storage, and Glance backs all of my sort of my persistent volumes and my ephemeral stuff and my images and so on. So okay, so that means I'm basically competing with other people about like for storage resources, right? And now there's something I can do with Ceph that is actually, or as the cloud operator, that is actually pretty neat, because I can sort of segment the access pattern to my storage, and I can basically guarantee a certain amount of like bandwidth or throughput or whatever to individual users, and I can do that through like basically various means of block storage QoS. Now, how exactly do I do that? If I'm a cloud operator, like what are the things that I need to think about so that I get sort of these QoS or limitation capabilities that I need in a cloud environment? So how to do that?
So I assume you're talking about the pools?
Yes, pools, for example.
Yeah, so Ceph allows you to define different pools. Pools can have different characteristics, like different quality of service. You can have a pool that is a fast pool, so to have fast backend storage like SSDs or even NVMe. Or you can have a slow pool that has backend or HDD hard disk. And you can have a pool that will be replicated and a pool that will be razor codes.
So what's the new stuff that kind of came up there just sort of a little while back, where I've been using like Ceph RBD for a while in OpenStack environments, and we always used VirtIO block for that, right? And now there's been sort of some advanced capability there where I can actually use a full SCSI stack with that. So how exactly does that work?
Well, there's VirtIO SCSI inside of QEMU, which allows you the SCSI protocol when you access the image. And now Ceph also has integration into QEMU with TCMU to have SCSI in.
What does that have to do with, say, trim and discard and so that sort of thing? Do I need SCSI for that, or can I do that with VirtIO block, or how does that work?
I think you cannot, only with VirtIO SCSI.
Right. So. And then what's cool about that? So if I can, so because I have this storage capacity there that is ultimately like 100% thin provisioned, because that's how RBD volumes always operate, right? So how does having trim and discard make that better for me?
So you can actually, discard means you can actually, and trim means you actually can free storage you used, which is something you cannot do with thin provisioning. Thin provisioning only goes. And
then actually return it to the thin provisioning pool, which is kind of cool, because then it becomes available to others, right? Okay. Now there's something that customers always ask me about, which is, all right, so Ceph is inherently uses like synchronous replication capability, right? So like within a Ceph cluster, all the replication that we do there for high availability purposes is synchronous. And then people always ask about, okay, well, what can I do if I also want an asynchronous replication capability? So for example, if I have a Ceph cluster here and a Ceph cluster over there, like in two different locations, and maybe both of those Ceph clusters back an OpenStack region. Regions are the way that we like geographically segment OpenStack clouds. And so I have an OpenStack region over here and I have an OpenStack region over there. They both have separate Ceph clusters, so basically the data high availability and replication and redundancy and so forth within each site is taken care of. But now what I want to do is I actually want to like replicate whole volumes over asynchronously to another machine or to another cluster. Now, how to do that, and how can I achieve that like within an OpenStack environment?
So RBD has mirrored volumes that you can use, and that's actually will do a asynchronous replication to a different region automatically.
And then apparently I can also like integrate that with CINDER-BACKUP itself, right? Which is like whole backup volumes, right? So this is not like ongoing replication, but the ability to like create a backup from one site to another. Like I have a live volume over here, and then I'm backing it up over into another site. All right, cool. And then there's other stuff besides RBD that I can use, where I can use Ceph in conjunction with OpenStack, right? So RBD is clearly like the most frequent one, but there's others as well. But before that, we've got a couple questions.
Is it mirrored volumes is a new feature?
So the question was, are mirrored volumes a new feature? Well, kind of yes, Joule and Newton. So Ceph Joule, we got RBD mirrored volumes, and then in Newton we got RBD mirror, and then in OpenStack Newton we got the ability to also include that with mirrored volumes. Mirrored volumes have been in Cinder for a while. I think it was originally built for NetApp. The API was added by NetApp and so forth.
So it makes sense for different clusters in different locations to have implementation with different Ceph pools with replicas inside this, each different region, or to use the mirror feature instead?
So the question was, does it make more sense to like spread this across 2 different sites, or to do things with different pools in the same region? The answer to that is yes. It's either or, and it entirely depends on like what you're trying to solve here. We're a little short on time here, so we can't really go into the details, and I'd like to take the other question that you had.
You're going to talk about object capabilities also, or
Next slide.
So the gentleman in the third row basically asked what our next slide was going to be, and our next slide was going to be about object store capability in OpenStack. Okay, so this is like your home turf, right? So besides RBD, like what's the other way that we can integrate Ceph with an OpenStack environment?
So we have the Redis Gateway, which is the cloud object storage gateway, which means that it provides REST API to do object storage. We support both Swift, which is the native OpenStack protocol, and S3, which is the Amazon.
Okay, and so that means I can actually use a Rados gateway that lives in my Keystone service catalog, just like a Swift endpoint.
Yeah.
And can I also, does that also mean it integrates, does that mean it only integrates with the Keystone service catalog, or does it also mean it integrates with Keystone authentication?
Both.
Okay, and then since you mentioned that we have Swift capability, but also S3 capability, can I do things like using the Swift API to create a container and upload an object into that container, and then use an S3 client and find a bucket that is named exactly as that container, and then retrieve those objects that way?
In some cases you can. Sadly, Swift and S3 are not fully compatible, so we like put in an object and getting it will work, but if you enable versioning, then because versioning implemented really different, it won't work, you cannot do it.
Right.
But yeah, for just reading an object or...
All right. And then finally, there's another thing that's kind of cool about Ceph, among many other things, right? And this is something that we hear all the time when we work with customers on this as well, which is...
I have a comment. So like where RBD, also Redis Gateway, we have geo application between different cluster and like regions, between regions like Amazon, so we also have.
Right, exactly. Yeah, that's another one. Yeah. Okay, and so finally, like one thing that we're always getting told by customers, which is kind of cool, is I'll get to your question in a second, is that Ceph is really kind of neat when it comes to like performance optimization for throughput, because it just scales out so beautifully. So like it's perfectly normal for a Ceph cluster to like saturate whatever the network bandwidth is. So if you have like a 40 gigabit per second network, if you have a properly scaled out Ceph cluster, you will be able to read and write from that Ceph cluster at 4 gigabytes per second. That is just going to happen. What was your question?
Do you have support at the API level to replicate? You mentioned gear replication. Is there an ability for the end user to replicate or ask for replication with gear level?
Okay, so the question was, what is? I'm paraphrasing here, but what is a user way, or are there? Do users have the ability to essentially set replication policies? And I assume you mean in Rados Gateway, so basically for object replication, right?
So I refer to the Amazon term, like you mean bucket policies. Those will be in Luminous. Next Ceph version will have bucket policies, so you can actually have a replication policy per bucket.
All right, so we're going to have to step on the gas here a little bit because we've only talked about the good things, and there are some things that are not so cool. So performance, like throughput optimization, is really nice, and the ability to do rolling upgrades, that's also pretty cool. So one of the things that you can do relatively easily in Ceph is to go from one version to another. There's no downtime that is customer facing or user facing. There will be some shuffling and some replication and so on, but generally this is a very, very smooth process. Okay, so those were the good things. Let's talk about the bad things. And bad things are things that you can deal with, right? Bad things are things that you can know and understand, but you can deal with. When things are ugly or when things actually go to the unknown, then it becomes a little trickier. Okay, so Orit, can you explain a little bit as to why in a Ceph cluster it frequently doesn't exactly shine when it comes to latency? Like performance optimization, when we're not talking about let's shove as much data into this cluster or let's read as much data out of this cluster as we can in a given time frame, but we have tiny I/O units that need to complete really, really quickly. So what are the pain points that we have there in Ceph?
So first of all is the replication, because we actually need to, every object you write, we actually need to replicate to list to other nodes. The latency of the network is a problem because you have to.
It can be a challenge, yeah. Right. And then there's another thing that basically applies specifically to Rados Gateway, but I really should have used this slide earlier because, of course, the gentleman in the third row already preempted that one again. So there are some things that are where there are still gaps sort of in the Rados Gateway and Swift compatibility. So in some sense, there's a little bit of a gap between what native Swift can do and what Rados Gateway can do, and can you go over those in just briefly?
I think the most big gap is the middleware. We can support Swift middleware, but that's because it's very, very specific to Swift and OpenStack, and it's not an API, so we cannot use that.
What about, say, global clusters, Swift global clusters? How do those compare to Rados Gateway replication? I mean, considering the fact that you've already rewritten the site-to-site replication once, right? So we had the federated gateway, and now we have multi-site replication. So how does that stack up now? How does that compare to things like Swift global clusters, where I can simply have basically something that looks like a single Swift cluster that I can just throw objects into, but in reality, it's a cluster that is replicated between, say, Singapore and Frankfurt and LA, and it will just do its eventually consistent magic to make sure that is in sync eventually.
That's the same.
All right, cool. How about ACLs? How about bucket policy? You mentioned. Are there currently any gaps, like for example in ACL support between Swift and Rados Gateway?
Well, the tenant, maybe you mean the tenant?
Mm-hmm.
Well, tenants, because S3 tenants and Swift tenants are very different. So we have something in between.
Okay.
And it's not fully computable. So we have some limits for what tenant can do.
All right, so it's not a 100% drop-in replacement. There are some gaps, but they tend to be relatively well documented, right? Which is why it's bad in some ways, like if you actually do need those features, but it's not necessarily ugly because you're struggling with things that are like poorly documented or anything. Okay, so let's talk about the ugly bits. So there's this thing that we call the drop or the cliff, right? Which is in Ceph clusters. Actually, this is specific to Ceph pools. You know, Orit mentioned that earlier. Pools are basically logical subdivision of your object store space, which is if you have a pool that takes in a ridiculously large number of very small objects. Okay, so. And this is, I mean, this happens, right? So let's say, for example, you're trying to write 20 million objects into your cluster per day, and you want to do that sustained over a period of months and months and months. Then, number one, we have sort of a gradual decline of the insert speed that we get into this cluster. And then sometimes we have these really weird situations where the input just grinds to a halt, where like for some time, the sort of the insert throughput drops to, like falls off a cliff, drops to almost zero. So can you explain like why that is and what we can do to mitigate that?
Well, Ceph uses the backend file system a bit more
unconventionally.
Yeah.
Right? Yeah. Yeah, unconventionally.
And it actually tried to do like a hash table from the directory structure. So actually what we call split is like a split in a hash table. So that means we have a very big entry, lots of objects in the same entry, and we want to divide it so the access will be faster. But sadly, that means we actually need copied, like to move the object from one directory to another. And the other side is merging when we have too many entries and want to make them one. But sadly, the action of merging and splitting is a bit heavy because we move with lots of symlinks and unlinked stuff in the file system.
And those are always slow.
Yeah. And also, it's many times what happens that all the pool gets to do the splitting and merging in the same time, and that's the drop, because all the pools at the same time. I'm busy doing link and link.
What can we do to make that less likely, or what can we do to like mitigate that? Are there strategies to like deal with that? So besides just not throwing as many objects into your pool, right? Because that's a cop-out.
Yeah, so there are several. One, you can actually do the split. Even if sometimes we recommend doing merge more, change the default and do merge much more slower, and you can actually do the splits. Make the splits less frequent. Another thing is doing, we call it pre-splitting. So actually, if you know you're going to have a big pool and you know the number of objects, you can actually do that before, and then you won't get splitting. And of course, there's the big step, which is
okay. And we're gonna get to the big thing in a second because it's one of the unknowns. No, not now, because we're short on time. And if we do have time for questions later, I'll be happy to take it. One other thing that people frequently complain about is this thing of I want to run a database in a VM on Ceph, okay, and then they find out performance sucks absolutely terribly. Like, why is that? Whoops, sorry. What does that have to do, say, with the whole latency problem?
Okay, so that's I actually can take your way. Once you called it database, people think they know everything about caching.
Well, no. Database people don't only think they know everything about caching. Database people are generally born with a genetic defect that has them believe that no one else understands caching at all, ever. You know, that's a no. So you know, if you're a database developer, I'm really sorry, but I'm not sorry.
Yeah. So there are databases are doing lots of caching and.
Well, they do their own caching is the thing, right? So, okay, so they do their own caching, and then that means that the block devices that they deal with, they disable all the caching whatsoever, okay? Now, how is that bad for Ceph with RBD?
Yeah, we talked about the Ceph has an issue with high latency, and caching is exactly the thing to solve by latency problems, but if you disable caching, that means you will have latency. high latency.
And then databases become really, really slow, right? So just in case you're considering like the use case of databases in an OpenStack environment, just a piece of advice that I can give you here, because it's not in any way Ceph related really, but databases are really a workload where you want to consider defining specific hosts, specific OpenStack compute hosts that you equip with pretty fast local storage, and then let your customers run databases there. That really is not a fault of Ceph's, really, but it's just that over the last few years, we've seen a fairly massive latency drop in storage devices that hasn't really been followed by an equal latency drop in networking. And we're talking actually in order of magnitude that things have changed here. And so it's generally such that if you're looking at databases, it's pretty much impossible today to find like any kind of network-based storage that can compete directly with like local storage, simply considering how fast NVMe or Fusion IO devices and so forth are, and considering how little things have changed latency-wise on the network side. We've seen great leaps in throughput, but we really haven't seen such great drops in latency on the network side. And then, of course, there's the option of InfiniBand, but with InfiniBand, that basically means that you're swapping out your entire networking infrastructure, and that's sometimes cost prohibitive. Specifically, if we're talking about something like a Ceph cluster of 500 nodes with like maybe 1,000 clients or something like that. Okay, so that's slightly ugly, right? So now let's talk about the unknown parts. And so you heard earlier that, okay, Ceph has this issue with working with local file systems, like through the OSDs, the object storage daemons. And now there's this new thing, it's called BLUESTORE, which I can assure you will solve everything. Okay, like basically it's going to solve all problems, cancer, world hunger, everything. So tell us a little bit about BLUESTORE and what that is about.
So actually, it's not only that we have the problem with the splits.
I thought you said it was not only going to be cancer and world hunger and but okay, never mind.
The fact that we use the file system with unconventional was make the OSD code more complex, because we need transaction, but file system are not really have transactions, so we do lots of file system sync and fsync, and that's can be costly. And then we have like limitation of file system, like Ceph. We don't like ext4. We actually have no problem with ext4, but we use extended attribute, and ext4 has a limit to the size of the external attribute, especially the name is very short, it's 256. So that's mean with RBD and the backend of ext4, you need really short image names, which is a problem.
Which is weird, yeah.
Yeah, it means 12. And that's led us to understand we need that file systems as a backend is not good for Ceph. We actually need to use the block storage directly as possible, and that's BLUESTORE. It's actually block BL and then new, just the EW, but it's blue because it's nicer, so that's BLUESTORE. Because
as you all know, there's this rule in like giving names to things, like don't ever call anything new because it gets old pretty quickly. And so I told Sage actually exactly that, because it was originally called NewStore, and I said, hey, listen, you might want to rethink that. And then luckily what they did is they did away with basically another like pseudo file system layer and just tossed it on block, and then it's a block plus NewStore is BLUESTORE. Okay, so finally, because we're running out of time here, what does that mean for like overall Ceph performance with BLUESTORE? What are the latest results from the?
But it looks like the right performance especially looks much better. We don't have any splits.
The directory splits are gone, you said?
Yeah,
okay. So we don't have that cliff? We don't have that insert cliff anymore? Okay.
Much nicer.
Smoother, okay.
And it also allows us to do optimization we couldn't do before.
Yeah.
And it looks promising, but then it's new, and it won't solve the cancer problem. I'm sorry.
Okay, when is it going to be ready for production? Like, what's the first Ceph release that we're going to see where BLUESTORE is going to be supported? Because right now BLUESTORE uses the most beautiful configuration option that you've ever seen in any piece of software. It's called Enable Experimental Data Corrupting Features equals BLUESTORE, which I think is glorious. But that designation is going to change with what release?
So next stable release, Luminous, BLUESTORE is going to be the default.
And that's going to drop when approximately? In the next 6 months, 3 months?
Yeah, well, I would never use a new version straight away. So
well, no, but like when is it? When does the version drop? When you're supposed to be able to use this?
Few months.
All right, cool. All right, and with that, I'm sorry. So Jeremy is basically waving his hands back there, and he's basically threatening to like come in with a hatchet that he's going to throw at us next. So we're going to wrap it up here. Yeah, see, there you go. So we're going to wrap it up here. Thank you very much for coming. I know that there's other questions that we were unable to answer. We'll be happy to take them outside, but we're going to clear the stage for the next speaker. And there's also stickers. If you're into Ceph and if you agree that Ceph is cool, there's stickers. Yeah, there's people with like laptops full of stickers. So with that, we're going to wrap up. Thank you very much for coming, and have a great afternoon. Cheers.